Hello guys, this is Amir from Bekhit, and in this lesson we're going to study the compound data types. So the compound data types in Rust are categorized into 4 groups: the arrays, the tuples, the slices, and strings, and also the slice string. Arrays are a fixed size collection of elements of the same type, of homogeneous types. So if you have integers, you need to have an array only of integers. If you have strings, you need to have an array only of strings. I'm going to declare a variable. The numbers are going to hold an array of 5 numbers: 1, 2, 3, 4, and 5. So of course we can leave it like that, but in Rust, as we said, this is a static type programming language, so we'll need to define the data type of the variable that you are declaring. So numbers, we're going to give it a data type of i32, and this is going to be inside brackets, like that, square brackets. So i32, then semicolon, because we need a second parameter. The second parameter here, or the second type of data, is the size of the array. So as we have 5 numbers, then the size of array is naturally going to be 5. So we'll do print ln. I'll do like this, and we can say number array, and we need a placeholder. And deliberately, I'm going to leave it like that. I know that we'll get an error, but I want to show you the error message. And do not forget the numbers variable. All right, so let's go ahead and run our application. So say rustc main.rs, and there we go. We have here i32 cannot be formatted with the default formatter. So the main problem is in the curly braces. In Rust, we have 2 types of formats. We have debuggable and display. So debuggable format and display format. And I'm going to explain that in detail in the next lessons. But for now, let's fix that by putting colon and question mark. So let's run that again. And we didn't get any errors. So we have our executable, perfect. Let's go ahead and run our main file. And we have number array 1, 2, 3, 4, 5. So what will happen if I will change a little bit in that? So we'll say, for example, mix. I know that's going to be wrong, but just to show you. So mix, we can say 1, 2, we can say here, for instance, apple. We can say true, and close that with semicolon, and let's print that, print ln. Let's run that again. And of course we have an error, expected integer found string slice, because we said that any array should contain the same data type inside it, homogeneous data types. So this is going just to comment these lines out, and let's get the last example for the arrays. So let's say, for instance, that we want fruits. In this case, we would want string or string slice. I'm going to explain the difference between string and string slice in a bit. But just bear with me to do that. We're going to have this ampersand str. That's not a string per se. This is a reference to a string. So as we did for the numbers, we're going to separate that with semicolon, and we'll need the size of the array. I'm going to give it apple, banana, and orange. Fruits array. Of course, we can return all the fruits, but also we can return some indexes. So how to do that? In this case, I'm going to leave it like this, and we're going to return the first element, which is apple. And let's do 1 and 2 as well. All right, so these are the first, second, and third elements plus the whole array. Let's go ahead and try that out. Now let's go ahead and run our file. And as expected, we have the fruits array, the whole array, apple, banana, orange, then the first element, second element, and third element. Next, we will explain tuples. So tuples contain heterogeneous collection of elements of fixed size. So what we have done here by adding one or integers, strings, and Boolean types, we can do it in tuple. But instead of those square brackets, we're going to put it inside parentheses. Let me declare a variable. I'm going to call it human inside parentheses. Alice, so that's a name, string rather, 30, which is an integer, and true, let's make it false. So this is a human variable. You can leave it like that, or even you can do like this. You can actually set the data type of each element. So Alice is a string, 30 is I32, and false is bool. So either way, it's going to work. Print ln, open parentheses, double quotes, and we'll say human tuple, and inside curly braces, we'll have also the colon and question mark, and we're going to pass the human here. All right, so let's go ahead and run that. First, let's compile. We have an error because Rust was expecting a string. Instead, it got a string slice. So I'm going to explain the string and string slice in a bit. But for now, let's just convert that. By the way, if you delete that, look, if you delete that, it should run okay. And we'll display everything. We have Alice 30 and false. The problem was caused because I've defined here a string. So this here, this is not a string. To convert that to a string, we need a special function called to_string. So this is going to convert this string slice to string data type. So let's just compile that again, and we didn't get any errors as expected. Run, and we'll have the same exact result. All right, this is going to be very clear to you when I will explain to you what's the difference between string and string slice. We can also have a mix tuple. So let's declare another tuple. I'm gonna call it my_mix_tuple. And this my_mix tuple is going to have different data types. Again, you can do like we have done here, just determine each data type of each element in your tuple, or I'm going to just leave it like that. So we'll have string Kratos, that's just the name, 23, that's integer, true, that's boolean, and even you can have a different data type, different compound data type like arrays. So let's try to put an array here. 1, 2, 3, 4, 5. Okay, and let me try to print that. We'll say my mix tuple, and of course we want this debuggable format like this, and we will pass my mix tuple. All right, let's go ahead and try that. Perfect, we didn't have any compiling errors. And take a look at that. My mix tuple variable has returned everything, including the array. Okay, so we have string, integer, boolean, and array inside the tuple. Now let's move on to our third compound data type, which is called slices. So slices simply are dynamically sized view into a contiguous sequence of elements. In computer science, and specifically in programming, contiguous sequence of elements is a very well-known term, especially when it comes to memory. Let's say we have this array here. We have 1, 2, 3, 4, and 5. So contiguous means uninterrupted, okay? Adjacent to one another. So when displaying something in a contiguous sequence form like an array, the memory doesn't have to jump between memories, but rather going one next to 2, element 2, the third element, the fourth element, the fifth element, they are all next to each other. And this is a very good thing for memory allocation and memory efficiency, of course. Let me give you an example about slices. So I'm going to declare a variable. I'm going to call it number slices. And that's going to be the exact same idea of string slice. We will have this ampersand. So ampersand in front of this array of 1, 2, 3, 4, 5. We can leave it like that, but I prefer to determine the data type of that variable. So I'm going to add and another ampersand, and inside brackets, we'll determine this as i32. We have a number slice. This number slice has an array. In front of it, we have this ampersand, but also the i32 as primitive data type has in front of it this ampersand. So let's try to print that. Now let's compile that. We didn't get any errors, good. And we have number slice 1, 2, 3, 4, 5 as expected. Let me give you other examples for slices. So we can have, for instance, we can have animals slices or animal slices, and that's going to have a different data type. It's going to be a string slice. So it's not going to be a slice, but string slice is a reference to a string somewhere in your code. I'm going to explain the difference in a moment. So we have this as stir, and instead of 1, 2, 3, 4, 5, we'll have different animals. We'll have lion, elephant, and crocodile. And I want also to change this a little bit. So let me just change that animal slice, and we'll have here animal slices. And finally, I want to have book slices. Here, I want a string and not a string slice or a reference string. So in this case, string, be careful, has a capitalized S, and we'll do the same thing as we have done here for human. So we have defined a string data type of Alice, and we have used the toString function. I'm going to do the same thing. It looks a bit bizarre, I know, but this is valid code. Let's go ahead and compile that. Good, we didn't have any errors. Let's check out what we'll have. Good, and as expected, we have here the number slice, 1, 2, 3, 4, 5, the animal slice, lion, elephant, crocodile, book slice, you know, the books. Now, speaking of strings and string slices, let's go ahead and check out the last data type inside the compound data types. The main difference between strings and the string slices is that the strings are growable, which means expandable. You can increase them or decrease them if you want, and hence they are mutable. So you can push and delete data from a certain variable if you want, and they are owned string types. Owned means that they are not borrowed, and I'm going to talk in details in a separate video about the concept of borrowing and ownership in Rust. And you need to know that memory allocation and memory efficiency is very important in Rust programming language. Rust basically is like C and C++, but much, much better. It has the best of all worlds from C and C++, as it's, you know, C and C++ are low-level languages. They are very, very, very fast because they're very close to your hardware, to your metal. C and C++ compile to machine code in no time. Rust actually does the same thing, but with no garbage collection and automatic memory management. When you declare a variable which is a string, actually, it's going to be allocated on the heap. And there is a difference between the heap and stack, and I'm going to talk about later. So they're actually allocated on the heap, and then these string objects can grow or shrink in size as needed dynamically. It's not fixed, but dynamic. It can grow, it can shrink, you know, you can add to it, you can delete from it. So this is done at the runtime in the background. So the memory allocation is made dynamically in the heap, but that's actually very, very slow to access because, you know, it's not fixed. It's wide, it's big, and it's slow actually when you have a lot of strings allocated and stored in the heap. But they are very useful because sometimes you want to modify your own string data dynamically, and that's your only choice basically. All right, so we spoke a lot about string. Let me give you an example. So you need to know that any data type in Rust by default is immutable, which means that you cannot change it. So if I'm going to declare a string variable, I'm going to give it the name of stone cold, and stone cold is of type string, okay? And that's going to be equal to string from, and we're going to say here, for instance, hell. Let me just try to print that. So print ln, let's say stone cold says, and we're going to pass here stone cold. All right, let's compile that. Oops, I forgot to have the placeholders. Okay, good. And we'll have stone cold says hell. Now, this stone cold variable is stored on the heap memory. Both the heap and the stack are the memory, okay? Just for you to not be confused. But I want to show you if you want to expand in that variable stone cold. What we can do, we can say stone cold dot a method called push underscore stir, open parentheses, double quotes, and we'll say here, yeah. All right, but as I told you that all of the variables in Rust language are immutable by default, you need to add the keyword mute before the variable here. So now you have converted this variable from an immutable data type to a mutable data type, and then you can do push string to add another word to your original data. All right, and before trying that, let me just put this here down. So let's run that again, and here we go. Stone cold says hell yeah. So we successfully have added or pushed to that variable a new word. So this is the string. It's mutable, it's ungrowable, it's an own string stored on the heap, unlike the string slice, which is stored on the stack. So this ampersand stir is a string slice, which is a reference, okay? This is not an own string. This is a reference to a portion of a string that it's stored somewhere in your code. They're also immutable, which means that you cannot modify anything. The string slices are used to reference string literals or substrings of string objects without needing to copy or own the data. So this is very good for memory efficiency because you do not have to copy the same variable. So these string slices are used when you want to work with string data without taking ownership of it. They also have specific size and no number of bytes to the stack. So the stack remembers that very well and reacts very quickly in contrast to the heap, which is expandable and, dynamic. It goes at the runtime in the background and can grow bigger and bigger and bigger and can be slower and slower. So that's the main difference between the heap and the stack. The stack is quicker, the heap is slower. But the stack can't have any mutable data types, while the heap can have dynamic mutable data types. So let me declare a variable here. I'm gonna call it string, okay? And this string has a data type of string written like that. So type string from, and we'll say here hell, or let's do hello world, okay? Now I want to declare a slice. So this is going to be a string slice actually. So say slice with the ampersand stir. And that's going to be equal to ampersand string. And as you can see that this slice is actually referring to the string. We haven't copied the value of hello world. So if this has a specific number of bytes, that's not going to be copied entirely. It's going to be only referred to the value that it's inside that string variable. Okay, we can leave it like that. Slice value and save. Okay, good. And we have slice value hello world. You can also determine what you want. So with the index, so if we want, for example, 1, 2, so 0, 1, 2, 3, 4, so we can say 0 to 5. Okay. And there we go, slice value, hello, only because we have, defined the number of characters that we want to return. One last thing that I want to mention here is that Rust cleans any memory allocated to any variable. So if you will try to display that slice outside here, you will get an error. It will yell at you, telling you that it's out of scope and it's undetermined. We don't know what is slice. Function, hello, or maybe print. And simply you are going to print ln and going to do like that. Slice, here we want the slice. Now take a look. When we will compile, we will have an error, not found in this scope, right? Cannot find value slice in this scope. And with that, thank you so much for watching. If you're new to the channel, please don't forget to subscribe and hit that notification bell to get notifications for our future videos. Thank you, and I will see you in the next video.